Hi friends, myself Vignesh Anand. In this video, we are going to see the testing procedures and also the test reports for a 132 kV CT, which means the CT ratio, which is having different types of taps in the secondary side, and also various cores are used in this CT. So we have taken one example as a 132 kV CT, and also for each tappings how the testing is carried out and the test procedures and also the test reports how it should be done, it under mentioned in this video. So right now, as I said, this CT comprises of 5 cores: core 1, core 2, core 3, core 4 and core 5. So as I said, core 1 and core 2 are having a taps of 2 taps, 1s1, 1s2, 1s3, which means 1s1 and 1s2 having a core 600 amps and 1s1, 1s3 having a core 1200 amps. In this CT, the secondary amps is 1, which means for all the core, the secondary ratio is 1. Likewise, core 3, the core 3 is our metering CT, which is having a 4 taps, which means S1, 3S1, 3S2, 3S3, 3S4. 3S1 and 3S2 comprises of 300 amps of current, and 3S1 and 3S3 comprises of 600 amps. Then 3S1 and 3S4 having 1200 amps. Likewise, core 4 and core 5 both are having a same. Next is that in here the accuracy class. The accuracy class, in the sense, the CT accuracy is mentioned as a it will be comes into a metering or a protection or a 5P10, 5P15 kind of protections. So that and all mentioned in your accuracy classes only. So in core 1, core 2 having special protection, so it is mentioned as a PX, and core 3 having 0.2 S, which means it's a metering core, and core 4 and core 5 is also a protection class. Next, knee point voltage. As I said, the knee point voltage should be carried for the protection core, which means protection special core of your CT. So the core 1, core 2 and core 4, core 5, for these 4 cores we need to do the uh, knee point voltage testing. So for the knee point voltage testing also, the voltage which we need to inject, that also been given. For core 1 and core 2, it is given as a 600 and 1200 amps, sorry, 1200 volt. Corresponding to that, the leakage current should be 40 and 20 milliamps. So 600 volt while injecting, we need to have a maximum of 40 milliamps as their expected value. It should be less than the 40 milliamps. Then for 1200 volt, it should be less than 20 milliamps. And same wise, core 4 and core 5 having a 3, which means it consists of 4 taps, sorry, 3 taps, which means uh, S1 and S2, S1 and S3, S1 and S4. So S1 and S2 having 300 volt, then S1 and S3 600 volt, then S1 and S4 1200 volt. So corresponding to that, the values should be less than 80 milliamps, then 40 milliamps, and then 20 milliamps. Then winding resistance also been given. Next, coming to the first thing, insulation resistance test. The insulation resistance test is used to check the healthiness of your insulation in the primary side, primary to earth, then primary to secondary, which means primary to core 1, core 2. In the sense, we need to individually give the inject the DC voltage, and then we need to measure the resistance value. Then secondary side to earth, that also we need to do done. Then core to core. So these all combinations will come into the insulation resistance test. So uh, the primary to earth should be having a 5 kV of injection. Then to the primary to core also been 5000 volt, which means 5 kV. Then core to earth and also core to core should be lesser voltage, because the turns, which means the winding which we are having in the secondary side will be very thin and sensitive. So for that we need to inject only maximum of 500 volt. So these are all the basics which we are doing in the insulation resistance test. Next, coming to the polarity test, as I have mentioned in my earlier videos, please come across with that video, because how the polarity testing is doing in the uh, substation I have mentioned in that. Let me come for the winding resistance test. The winding resistance value has been given in the nameplate detailed itself. So the value of your winding resistance should be lesser than the factory defined value. So normally the winding resistance will be measured in your multimeter itself, or any LCR kind of meters. So next we are going to the knee point voltage test. Normally the knee point voltage test should be carried for the protection special core only. So in here we have a 4 protection special cores. For all the 4 cores, we are going to give the voltage and check the leakage current. So in the earlier video I have mentioned, or I have explained how the connections will be done for the knee point voltage test. So please refer that earlier video. In here the report says that the in core 1 and core 2, S1 and S2 point maximum of 600 volt, which means 110% of the 600 volt, in the sense 660 volt we will give. So 660 volt, in the sense it should be less than the 40 milliamps. Then for 1200, in the sense 110% of the 1200, 1320 volt we will inject, and then the leakage should be less than 20 milliamps. So for core 4 and core 5, same. For S1 and S2, 300, in the sense 110%, 330 volt we will inject, and it should be less than 80 milliamps. Then for 600, 660 volt, 110%, 660 volt, it should be less than 40 milliamps. And for 1200 volt, 110%, 1320 volt we should inject, and it should be less than 20 milliamps. So while doing the knee point voltage test, the secondary side will be in open condition only. So because we are going to inject the voltage on the secondary core only, the primary we don't need to do any shorting or anything. So we are going to inject the voltage on the primary secondary side, and we are going to measure the leakage, which means by using a ammeter or a tongue tester we will measure the leakage during at the time of injection, and the leakage should be less than the predefined or factory value. So by this testing we will define the saturation level of your CT, and also the curves, saturation curves are being done. Next, coming to the ratio test. So in ratio test, for core 1 and core 2, S1 and S2 point 600 amps maximum, and for S1 and S3 1200 amps maximum. So as per the connections, we will using the loading transformer for boosting the current, and then injecting the current up to 1200 amps. So as per this, we are going to inject an amps and then measure the secondary current, and that measured secondary current should be equal or more or less less than the error percentage of your actual current level. So for core 3 and core 4, core 5 also been I have mentioned as per the nameplate detail. S1 and S2 300 amps, S1 and S3 600 amps, S1 and S4 1200 amps. So how to calculate the actual secondary current? So because we will measure the secondary current by using tongue tester, and also we will measure the primary current by using the tongue or anything, but we need to calculate the actual secondary current for error calculation. So for that what we do, we just have a one formula. We as earlier, we will easily know the rated primary and secondary current. Please refer that below red marking formula. The rated primary current divided by rated secondary current, this means the CT ratio, is equal to injected primary, what current we are going to inject, divided by calculated. In here, calculated or actual secondary current, which is we are going to calculate. So the calculated secondary current will comes to one end, and this primary rated primary divided by rated secondary will goes to another end. As per the max calculation, normal calculations, you will be able to find the actual current of your secondary side. So for calculating the errors, error percentage is equal to measured current, which means the measured secondary current which we measured in your leakage test minus actual current divided by actual current into 100. So this is your error percentage formula. After this, the error which coming to the result, it should be lesser than the value as mentioned. It should be lesser than the value as mentioned, because the for metering the error should be very lesser, because it's metering equipment, in the sense it should be very accurate, or more or less it should be an accurate level. For protection also, it should be also be in a accurate but not much, because for protection we may have a like a 1% of error tolerance, but for metering we may have a only 0.2 or 0.5% of tolerance only. So these and all the basics testings carried out for the CT in substations. Hope you understand. I think so. I have taken just one example only. So keep share your knowledge and gain your knowledge. Thanks everyone. Nandri Vanakkam.